last week. Let me see where we stopped last week. This is the notes that I sent to you last week, right? So let me see where we stopped. Query 5 points. Which query did we? 5.4. We stopped on query 5.4. So we're going to do. There were five cases of that particular wildcard instance that we said we will look at, plus the null factor that we said we will look at. We finished with the wildcards. Now we look at the null. So the case of the null. So that is the next search condition. Let me see. Can I continue from this? Can I continue from that? Yep, I think this is what we were doing last week. This is what we were doing last week. Right. Are you recording? Is it being recorded? Okay, cool. Right. So let's see. We have query 5.5, query 5.5. No. Search condition. Now, there are two forms of this null search condition. If you remember, I said the first one is null. And the next one is not null. These are the two conditions that we have. So let's see if we can create a search where we will use these search conditions. So we select, what do we want to select and where do we want to select from? Let's follow what we were following the previous time. Select person ID. Person ID start date. Actually, I can just copy this from somewhere and dump it. Okay. Start date and then pay type. Pay type. Where do we want to take it from? We want to select these from pay elements. From pay elements. Right? We want to select these from pay elements. Now we apply the search condition. So to apply the search condition, we use the where clause. Where, what clause, what do we want out of this? Let's say that we want to look for the end date of the employee. Where end date is null. Now, who can tell me? Look at this statement carefully. Who can tell me the meaning of this statement? Especially the where clause. What does it mean? Let me rephrase the question. In which instance of an employee life cycle will the end date be null?
Maybe if I'm right, maybe perhaps.
We can't hear you. You are so far away.
Well, I'm close to the system. Okay. Maybe can you hear me now?
It's slightly better now.
Okay, maybe perhaps when the person has stopped working, maybe he has retired or something like that, or he's retrenched or something like that, if I'm right.
Okay, so that's one idea. Who has another idea? Who has another idea?
If the employee is in a permanent job,
Employee is in a permanent job.
I think so.
So will the employee be will the employee be working for life? Permanent job.
Could it be at the start of the employment?
At the start of employment.
Or maybe when the end date is when you know the end date.
When you know the end date.
But for those employees that probably have retired or something, or they are.
Well, that's so you've just said what the first speaker said. Now think carefully about this. If the end date, if the you know when the person has retired, then the end date cannot, mind you, we said null is something we don't know. We said null is something. It is definitely something, only we don't know what it is. So at which stage of an employee's life cycle would we not know their end date? If that helps. Come on, someone help me here.
Would it still be the start, as I mentioned?
Maybe the start, yeah.
When
not necessarily the start, when the person is still in employment. We don't know when they are going to stop working. Do we? If you are working now, do you know when you will leave that particular job? Unless, of course, you've planned to leave. Then you know when you want to leave. So when the person is still in employment, their end date is null. We don't know what it is. We don't know whether they're going to leave in July or they're going to leave in December. We don't know whether they're going to leave on the 1st or on the 31st. We don't know. So the end date is null. So that will be for people who are still in employment. So let's run this query and see what we will get out of this. This is what we have. Now, I want you to take note of something. How many rows of data do we have in this query? Or how many rows of data has this query produced?
121. 112.
112.
112. 112. Okay. Now, let's run a counter query. Let's run the opposite. When the end date is not null. When the end date is not null, what does it give us? Check the number we have, 112, right? So these are people who have left employment, either by retirement, by redundancy, sack, whatever it is, they've left. They've left employment. So here their end date is not null. It is not null because we know the end date. We know when they left. Right? We know when they left. Now, how many rows are in this data sets? How many rows are here? 35.
35.
35. Okay, the first one we had 112. Now, if we were just to run this query, just this one. This gives us all the employees there in the business. Select person, ID, start dates, pay type from the pay elements. So this gives us all the employees. How many do we have? 147. Now 112 plus 35, you would agree with me, is 147. Right? So simply it's telling you that with these two queries, we have been able to sort out all the employees in the business who have come and gone and are still there just using these two queries. Just using these two queries. We've been able to achieve that. And it wouldn't matter at all if we had a data set of 1 million rows. It wouldn't matter at all. It will yield the same results. You will be able to work efficiently with the same set of queries. It wouldn't matter at all. Right, so this is the power of SQL. Now, I want you to take note of something here. I'm going to run another query on this same thing. Where the end dates is equal to will this work? Who can tell us what this is? The space in these inverted commas. Do you think that would equate to null? Of course, there is empty, isn't it? So will it not be null? Yes, can someone help me here? Can someone tell me? I need you can you please unmute? I want us to be as interactive as possible so that the class will be interesting. Yeah. Yes, so Kemi, what do you think would happen here if we were to run this? I'm going to call people if you are not going to respond.
It most likely won't run because it's showing as red.
Oh no, that's not why it wouldn't run. It's inverted commas. Remember?
Does it need a string, something to type inside or what?
Oh no, not at all. Not at all.
I'll keep quiet.
Mind you, this one run, but it's also in red. Right? It will not run the red if it's underlined. This is showing a different data type. That's using showing string data type. Right? So that's not the reason at all. It's not the reason why it's red. No. It's a perfectly sound query. There's nothing wrong with the query, but it will simply not yield any results. Let's run it. It will not yield any results. And why is that? Remember we said that null is something. Null is not just an empty space. Null is something. So when you have put an empty space here, you are not talking about null. We said null is something, only we don't know what it is. And that is the mistake that a lot of people make when it comes to using null. So it is a it's a tricky one, but very, very important. And it's best you understand it right from the beginning. Null is something. It is not empty. It is not zero. The only problem with null is that we simply don't know what it is. Is that making sense? So this is not going to run because you have not told the query, you have not told the query anything about this clause here. You haven't told this query anything about this clause. So the query is as confused as confused.com. Right? So it wouldn't going to run. It's not going to run. Right. So that brings us to an end of the conditional of the conditions for the use of where clauses. We've looked at 5 main conditions. We've looked at the conditions of, we started from, yes, who can name them? Can anyone name them? Range, we look at range, we look at set membership, we looked at comparison condition, where we use the mathematical comparison statements, equal to, greater than, less than or equal to. We use all those things. Not equal to, we use between, that is range. Then we use set membership, that is the in and not in clauses. Then we use pattern match, where we talked about the wildcards. Remember? We talked about the wildcards, the percentage sign, and then the underscore. And now we have spoken about null. So these are the 5 conditions that we can put in the where clause. These are 5 conditions. Now let's quickly go on to something that was also planned for last week, but which we couldn't finish. And this is sorting by order. Remember the format of the select statement. I said the first 2 were the most important. Select from. These first 2 statements here are the most important statements in the select structure. Where did I write that? Where did I write where did I write it? Where did I write it? Did I write it at all?
I think 5.1. So
5.1. No, it's not under that. I did that right for, oh, okay, that's on another, right, that's on another, it's on another, so what was sent to you? What did I send to you? What did I send to you? Let me see. Let me go back and check something. Sorry about this. Let me just quickly check something. It was posted to you, right? Something was posted to you last week. Or was it not? Okay, let me go here. I think I sent it to Allow. Oh yeah, that's it. So this is the format of the query. Can you still see my screen?
yes.
Yes.
Okay, so this is the format of the query. Select from, these are the 2 most important, select and from are the 2 most important. That the select statement is the most widely used statement in SQL. The select statement is the most widely used. Then from, because you have to select from somewhere. Now, the where group and having are conditioned on what is required, where group having an order. But order is also quite commonly used because it is mainly used in sorting. Now, grouping and having are based on certain other conditions, which we will talk about later, moving forward, not today. So today I want us to look at the order by, right? Mind you, these two are the most important. These other ones are used as and when necessary. They are used as and when necessary. Right, so let's go back. Where is my stuff? Sorting. Let's look at how to sort. We sort using the order by clause. Sorting. Where did we start today? 5.5. Okay, so let me just underline this so that I know what to send to you. From here, we started from here. Today is 10. Right. Sorting. When you have run a query, sometimes you want to sort the results, especially for data analysts, because you want you want to present to stakeholders something that is appealing, something that makes sense, not something that is everywhere. So one of the ways is to sort. You will be doing a lot of sorting when you're using data. And to sort, you need to use the order by clause. Order by clause. It's a very simple clause to use. Let's see. Rather, let me run this differently. I'm going to select everything. Select all. From employees. Select all from employees. And you want to order by some criteria. How do you want to order? Is it by their surname, by their first name, by their date of birth? By their pay structure? How do you want to order? So you determine how you want to order your data, such that it's appealing to your stakeholders. So let's say you want to order by their surname. Order by surname. Order by surname. Okay, let's run this and see. Let's run this and see what it would give us. And then we will look at two keywords that go with this kind of query. So this is what we get when we order by surname. And then you would see that it has sorted out the surname in alphabetical order. It has sorted it out in alphabetical order. Can we see that? Sorted out in alphabetical order. Now, when you run a query like this, you can either decide to sort in either ascending or descending order. The default position is that SQL will automatically sort in ascending order. It will automatically sort in ascending. So from the first going down, going up, right? So assuming A is 1, B is 2, C is 3. So A, B, 1, 2, 3. So in ascending order, right? Automatically. So that if I were to run this slightly differently, if I were to run this slightly differently, there would be no change whatsoever to the results that this here produced. This and that are the exact same statement. If we run it, we get the exact same thing. It's sorted still on surname in ascending order. So ASC here is ascending. However, if I were to run this in descending, DESC is descending. Now look at it carefully. There's a complete switch now. The surnames are starting from the highest, assuming you number A is 1, B is 2, like that. So Y will be number 25, isn't it? There are 26 letters in the alphabet, X, Y, Z. So Y is 25. Then W coming down. So this is descending order. Descending order until we get to A. Right. Let's take it one step further. We can sort on more than one criteria. Sort on more than one criteria. We have, right, surname, forename. Surname, forename. If we were to run this, see, oh gosh, see what is going to happen here. And just tell me what you think is happening here. We are sorting on surname, forename. Can the two happen at the same time? You can see that obviously not. This first takes precedence over the second. So this is the precedent condition. The surname here is precedent to the forename. So that happens, all of this will be sorted out before that. So that if I were to switch these terms, if I were to switch them, It doesn't matter if I put a semicolon there, right? Like I told you, it doesn't matter. If I were to switch them, see what is going to happen. Look at the format we have for now. See where this format, the first forename here, that is Rita, right? Let's see if we run this, what would happen. What now takes precedence? The first named object of the query of the order by takes precedence over any other one. So this will be sorted out first in ascending order, unless of course you specify that it's descending. Like I said right from the beginning, SQL sorts by default in ascending order. Right? It will sort by default in ascending order. So this now gets sorted out first. Right. Any questions so far? Any questions? If we were to sort this in descending order, let's see what would happen if we sort this.
Just
Pardon?
can we sort by, let's say, sort by surname and then by gender? Would that be possible?
Of course, but then the first named object will take precedence.
Okay. So, but we didn't have to sort by gender too, which one?
So it will sort out all of the surnames before sorting gender.
Okay.
So definitely in the arrangement here, you are going to see surname, 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 surname sorted correctly, and then there will be a mix of gender. So the first named object is what takes precedence in the criteria, in the sorting criteria. So let's try it. Yes, let's try it and see what we will get. Let's try it and see what we will get. Surname. Do you want surname or forename, or it doesn't matter?
It doesn't matter anyway.
Okay, let's use gender. We wouldn't get anything different from what we already have here. I can promise you that. So what happens is that it sorts out all of these here. Now it's sorted out in ascending order, right? So it sorts out all the A's. Now it does happen that all of these are male, 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 female, female, female. Yep, but that's what we have. So it doesn't change anything at all.
Okay.
Any questions before I bring this part to a close? No question, right? Okay, so if no question, let's go on to our joins. Let me create a new query sheet. Joins. Now in SQL, there are 6 types of joins. 6 types. Six types of joins. 1. We have what we call the inner join. or simply put, join. So where you see join is also called, it's also inner join. It is best to use inner join so as to give a distinction to the type of join you are doing. So in most cases, you would see inner join. But if you just see join, it simply means it's an inner join. Now we would explain what all these mean. Then 2, we have left join. Right join. Right join. We have full join. We have what we call the cross join. And we have self join. I hope we'll be able to finish these before 10 o'clock, before 11. Right, so these kind of joins are what we have in SQL. Now, what are joins used for? Can anyone tell me, just by the name that you hear, join, what is it? What is it all about? What do you think a join is used for?
To bring things together.
Exactly. So as a data analyst, you want to be able to bring something from one table and join to something from another table. Right? You want to be able to put things together. That is what the joins are for. Right. So let's talk about inner join. The inner join is used in join, like the name implies. It's used in joining if you have two tables, the inner parts of what is on the left and what is on the right. We will see how that works in a bit. And when we are using joins also, we use a lot of aliases. I think I mentioned aliases in the last lesson, in the first lesson we did last week. So an alias is where you assign a shorter form of a name to a name. So assuming I want to call Kayode K, K is an alias for Kayode, right? Something like that. So how do we use an inner join? Let's say we want to select. Select all. Where are we selecting from? Let's say we want to select from employee table. We use employees a lot, right? From employees. And at this stage, we give the employees an alias so as to make it easy for us to write our queries. Let's call it E. So what is it going to join on? Inner join this. Inner join the employees table with addresses table, so that when you see an employee, you will know their address. Is that making sense? So you have an addresses table. For example, in the UK, there is a database for addresses for all homes in the country. And also, we have different people working in different places. Assuming you don't know where anybody is for the very first time, but you want to find out, you have a data set of employees who live somewhere. You don't know where they live, but you now want to match the employees' names in your business with their addresses. Because mind you, in the addresses table, their names will still be there. If they live there, their names will be there. Unless they don't live there. So it's like the electoral roll in the UK, where everybody registered, everybody who lives in a house is registered on the electoral roll at a certain age. So once you go into employment, even if you don't give your name to your employee, they can still search you out. To your employer, sorry, they can still search you out, right? Simply based on your name and a few other details. So you want to join this on addresses. Let's give the addresses alias A. Now, how do we want to join them? That is where we use on. We are joining employees and addresses on what criteria? Take the employee, his address, in the employee's address, employee address ID. This should be equal to what we have in the address table. Right, this is what we have. This is a join statement. We are using an inner join here. We join in address, employees' addresses, right, on the addresses. The table of employees and the addresses, and then the table of addresses. Am I making sense? So it's like we are searching for the employee's address in the employees table and joining it onto the addresses address in the address table. That is what we are doing here. Now, if we run this, we get a result. This is the result that it gives us. So it takes the employee, the person ID, and joins on the address ID. Okay. So it takes the employee's ID, the employee, and joins on the address ID. Where is the address ID? Where is the address ID? Address ID. You see that address ID actually appears twice in the table. So address ID, address ID. That's how the joint happens here. Right. We will come back to this after we've done one other join. We'll come back to this. Let's leave this for now. We'll come back to it. Once you've gotten your first statement like this, the others are just easy peasy. They just follow. We want to do a left join. That is one, this is one, this is two, left join, two. Left join. Oh, come on. Left join. Let's just change this to left. That's about all we need to do here. Now, what is the meaning of that? Now, this shows that the left join simply says that it will take all the rows from the first table, but so you have two tables, left and right, right? One table is considered to be on the left and one on the right. Right? One on the left, one on the right. So it takes everything in the left, all rows in the left, and join with what is matching records in the right. It will take everything in the left table and would join it on to matching records on the right. So everything in the employee's address table and we'll join it to matching records on the addresses address table. The inner join joins everything together. Everything on the, okay, let me leave that. We'll come back to that, like I said. And let's run this and see. Now, mind you, the first one, how many rows did we have when we run the first one? 108. Let's see what we're going to get here. Let's see if there will be a difference. So it takes everything on the left and joins it onto what is a matching record on the right. Now, what this means is that if there is no matching record of what is on the left, on the right, it will not join. Is that making sense? If there is no record on the right, it will not join with the left. That simply is what this is telling us. Right. Let's look at a right join.
Excuse me, sir.
Yep.
Is there a difference between this? Because what I think I understand is if it doesn't see anything to join on the right, it will null it, as opposed to not join.
Yeah, so if it doesn't see anything on the right, then the record will not show. So it doesn't select that record. Do you get it?
Okay, I think so, because I saw this date modified just shows none across.
Forget about the nulls here. Okay. Mind you, these ones, so if the date modified here is null, that means that we don't know when that is going to happen. It hasn't been modified. That is why it's null.
Okay.
Sorry, can I also ask a question, sir?
Yes, please do.
Please, my other colleague has spoken based on our knowledge about Tableau. Actually, we were told that we have 4 types of joins. Should I say joints or joins in the Tableau? Now we have 6. But seeing that we have done inner join, we have done left join. And most of the times, if we are working on Tableau, we look at the 2 tables, or perhaps maybe 3 tables, and then okay, let me say just 2 tables, and then we know, okay, we want this and we want that. But on what basis do we do this in SQL? Because I didn't see you really looking at the 2 tables to say, okay, I want this field, okay, this one has this, and then I'm bringing that together. Then I can say I should use left join as against right join or inner join. So I just want to.
Don't worry, I will tell you when to use all these joins in a bit. As we do, once we do the right join, we would see when to use the left, the right, and the inner. Okay.
Okay, thank you, sir.
Right. Now, I think why you are told there are 4 is simply because the first 4 are the main ones. These first 4 are actually the main ones. It's not like the other 2 are not main. This one, the 5th one, is actually used by mathematicians for mathematical operations. Right? This cross join is used for Cartesian operations. And the self join is actually one of these. It's one of these, and we will come to that also. That is why a lot of people will say 4. But there are clear distinctions between them, which is why in SQL we separate them.
Okay, sir.
Right.
Thank you, sir.
So a self-join simply means joining a table onto itself. That is why it's called self-join. So in a little while, I will tell you that there is actually nothing like self-join. If we had come to that before you asked your question, that is what I would have said. That there is actually nothing like self-join, but it is taking a table and joining it onto itself. It's the operation that gives it the name. Do you get the point?
Yes, I get it, sir.
So like here, we have employees address and then addresses address. In a self-join, you join the table onto itself, a particular table onto itself. That is how the self-join comes about. So it's in the operation that we have the name. But when we are writing the query, we actually don't use, we don't write it out like that. Okay?
Yes, thank you.
So let's look at a right join. R-I-G-H-T. You will see something interesting with the right join soon. So all we need to do here is just, who can tell us what we need to do here? Let's just change this to right. And then run it. Now see, this is the left join. See how many rows we have. 136. Let's run this and see what we will get. 109. Right. So with a right join, what happens is that even where there is no matching record of something on the left in the right, it will still join. Even where there is no matching record, it will still join. Now, so why is that the case? And of what use is that? Let's see something interesting. Let's scroll down a bit. I want to look for something. Okay, so look at this rule carefully, 106. It gives us null throughout. So why is it part of the result? Why are we getting a result for somebody who is non-existent that we don't know in an employee table? Why are we getting this record?
Because we have the ID from the right.
Where is the ID?
Because we have the address ID on the right.
Yeah, there's an
Which are
address
joining
here.
to the left.
There's an
which
address
is not
here,
available.
but there's no employee at that address. There is an address here, all right.
From the right.
Right? From
Yeah,
the
because we are
right.
doing the right join. Everything on the right will take. Then whatever we don't see on the left won't be there. So there's nothing on the left. That's why you wrote it down.
Right. So why has it why is it, of what use is this? That's the main question I'm trying to ask here. If there is no employee at an address, why is it giving us the result of an address? As an employer, I am only interested in where my employees live. I am not interested in other properties that do not have my employees. Am I making sense?
Yes.
So this a right join is not a recommended type of join. It is there, you can do it, but it is not recommended. It is not advisable. You should never, ever do a right join. So assuming you go for an interview and they ask you, how will you handle a right join? What will you say?
Not recommended.
So what will you do? How to solve the riddle of a right join? Riddle, is it? Riddle, is that a spelling? How do you solve the riddle of a right join? It's simple. Just switch it to a left join. But in doing that, you need to switch the tables also. You need to switch the tables that you search from, and on your join query. So switch the tables and switch this right to left. This is very important, please. Assuming you are asked at an interview, don't come back and tell me you didn't get it. And if you are going for an SQL interview, chances are that you could be asked this question. So switch, you're searching on addresses. Okay, let me rewrite that. You are searching from employees. You are selecting from employees and joining onto addresses. So switch the tables and change your right to left. Does that make sense? Switch your tables. So this now becomes addresses. This becomes addresses. This becomes employees. Employees. Is it double S or double E? Oh, this is a spelling for employees, isn't it? Employees E. On E.addresses, E.address ID should be equal to address ID. That's all you do. Switch the tables and change your right to left. If we run this, see what is going to happen to this row here. Let's see if it is still there. It was on 106, right? Let's see if it is still there. It has certainly vanished. We don't have that ghost worker anymore. So previously we had ghost workers, right? We had ghost workers in the table. Now there is no ghost worker. Every worker is accounted for. Every worker has got an address. Or every address we have in the table has got a member of staff living at that address. Is that making sense?
Sorry, but there's no still member of staff.
Pardon? I didn't get you.
Sorry, I was saying there's there's no still name. It's still showing none.
Where?
On 106.
Where?
The 106. Take 106. Still showing almost the same thing. We still have the address.
Where? Here.
Yeah.
Where is it?
There's no still employee number.
No, but there's an employee here. This one has got an employee. It's an employee.
That's an address, but there's no employee. That's address ID. The person ID and employee number is none. It's almost the same thing like what we had before, because we're just showing none for the same, but it was showing an address. So we said there was no employee on that address. So now it's almost to the same thing, because we have just the address, but we don't have an employee to that address.
Right. I get what you mean.
Yeah, so we just have the address, so there's nobody exactly in that address, no employee ID, no person ID.
Okay, I get what you mean, but we have an address, right? We have an address, but it's a vacant house.
So what we did the
What
left
we did the last time was saying that we don't have an employee, but
we had an address.
We have an address.
Yeah, so I think it's the same thing now because we
but
have
it means differently.
Okay.
The meaning is different.
Okay.
Right? The meaning is different. The most important thing is that you, assuming this were staff quarters, there could come times where staff quarters could be vacant.
Okay.
Right? But there will be no time where you don't have an employee in your system, but then you have an address. Look at it differently from a staff quarters this time around. Are you getting my point? So it's just like what would happen, for example, where people register fictitious names on a voters register. There is nobody at that address, but there is that person. There's a registered name on a voters register. So a ghost name, for example, existing on the voters register. It shouldn't happen. That is essentially what this is all about. Is that making sense? Is that making sense? I don't know who has the question, but is that making sense?
Yeah, it does.
Right.
It does, yeah.
Okay. So let's go to how many minutes do we have left? Just about 30 minutes. Okay. Let's go now to the full join. The full join, as the name implies. Okay, let me give you a few distinctions. Yeah, let's go back to I said I'll come back to the inner join. The inner join is good for performance. So where you want every kind of bit of information, you use the inner join, but it runs the risk of losing data. The best out of the 3 joins that we have discussed so far, the best is the left join. Is the left join. But you would also occasionally use the inner join if you want to get if you want your results, if you want performance out of your results. But then you could lose data by so doing. So out of the 3, the only one you shouldn't use is the right join. So let's look at full join. So where do I copy this from? So that is 4, right? 4 full join. So again, let's just say full join, right? Let's choose this one to full join. Full join. That simply means joining everything. And it's mainly used when you are comparing different data sets. You want to know exactly what is in all the data sets. That's when you use the full join. So it's the same format, full join from select from employees, full join addresses, alias A on, employees address ID being equal to address ID. So if we run this, let's see what we get. I think this should give us everything in the database. I don't remember, but let's see. Yeah, it gives us everything under employees table. It gives us everything under the employees and addresses, right? So these are the four main, like you said, 4 main types of joins. These are the 4 types of joins that you would normally be told, right? These are the 4 types of joins. We're going to look at another type of join called the cross join. Like I said earlier on, this is mainly used in mathematical operations, the cross join. And I'm just mentioning it for those who want to know. With this, since we want to do something mathematical, I will need to change the table. Let me change the table to this. And this is a simple let's just see what we have. Select all from, let's see. Select all. Let's run this statement and see what this would give us. This is all we get from that. And if we run this, let's see what we have. Do we note a difference? This is just giving us that. And this is giving us that. Right, so this is like, I'm not sure if there are any one of us, but I believe data scientists, all of you would have done a little bit of mathematics. You would all be conversant with the XY axis, the Cartesian plane. So this cross join is mainly used in working on data on the Cartesian plane. So you don't need to know it, but it's just for those who would like to know. So if we want to join table 1 and table cross join 1 and cross join 2, so select from cross join. The tables are called cross join. Cross this. Cross join this. Cross join with cross join 2. So that's table 1, which we saw earlier on. This is table 1. And that's table 2. If we put them together, we get a Cartesian product. So you would see that 1 has been matched to each letter, 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. So there is a match between each. So each X and Y, X and Y. Anytime you have an X, you should have a corresponding Y. Is that making sense? That is where you use the cross join. We will not dwell much on the cross join. So quickly, let's jump onto the self join. Maybe you should even have left this to the last, the cross join. So let's look at the self join. This is 4, that is 5. 6. Let's look at the self join. Where do I take this from? We want to join one table to another. This is under training. Okay, so we can use that. Right, so let's select again from here. Select everything. Let's use a different table. Let's use this manager hierarchy table. Manager hierarchy, and let's give it an alias of employee emp. I'm going to do 3. Remember when I spoke about the self join the first time, somebody asked a question and I had to use the self join to explain. I told you then that the self join gets its name simply from the operation of the join, not that there is anything called a self join, not that there is a self as is a word in the statement, if you remember that. Now, and I did mention that the self join operates on one of these 3, inner, left, and right. And I think straight away you can see that we would have to rule out the right, because I did mention that never use a right join. Right? So even if the self join were to be done on a right join, because we should never use a right join, we would never use it. Right? Okay. So let's see. So the self join we can conclude should be either done on an inner join or a left join. So how do we do that? So we want to work on this table. Let's do the inner one, inner join. Inner join, manager hierarchy. Manager hierarchy. Man. That's an alias. On. In the manager hierarchy, in this table, if we were to, okay, let's just see what we have there. Let's look at this first. We're selecting all from manager hierarchy table, right? So what we have here is person ID, full name, and manager's person ID. Right. So we want to hear we are joining on the employees. The manager, mind you, the manager is an employee, right? A manager in a business is also an employee, but he's a manager. So it's an employee who is a manager. Is equal to the manager who is a person in the business. He has a person ID. So we are joining this table onto itself. This is the table. We are joining it onto itself using the inner join. So this table is from the manager hierarchy. And we are joining the manager hierarchy on the manager is an employee in the business. So we are joining their personal ID onto their manager's personal ID. And if we run it, this is what we get. This is what we get. We can also use the left join for this. All we do is to change that to left. One of these is better to use, not both. If we run this, this is what we have. Do we note a difference? Any difference at all? Let me run this again. So we have this manager. And that is their manager. This manager, that is their manager. This manager, that is their manager. Same. This manager, that is their manager. This manager, that's like that. And we have this manager, that's their manager. But you see, this is a bit difficult to read. Let's look at this one. Not difficult to read, difficult to follow. Yeah, it's the same thing, isn't it? And someone would say, are they not the same thing? No, they are not. Like before, this person's manager is that. But we see here clearly, this person shows clearly here that this person hasn't got a manager. Why is that? These are all the top bosses, all the managers in the business. So there should be one of the managers who shouldn't have a manager, and that should be seen clearly. Because this person here is the chief. That's the CEO. That's the chief of all the managers. They don't have a manager. And that should be clearly demonstrated. That should be clearly seen. Right? Is that clear? Any questions so far? Any questions so far? We can go 2 more steps further on this, but I think I'll leave it here so as not to confuse you. But this can be actually dealt with in a better way to get a better table. But I want you to get the understanding of this first. And then maybe next time we can look at there are only 2 more steps left on this actually. But I would like to leave it at this stage. So has anybody got a question? Or are we all in the kitchen?
No, yeah.
Right. If there are no questions, let me wait for 1 more minute. So I'll be sending over the notes to you so that you can see if you can use it on your database. But with this particular, with these last 2 joins, it will depend on the kind of data you have in your database actually. Obviously, you can't do a cross join if you don't have statistical data, mathematical data in your database. You can't do a cross join. If you can't do, if you don't have data that can be plotted on the Cartesian graph, you can't do a cross join. But you should be able to do all the other kind of joins. So the best form of a self join is actually the left join. the left join. As much as possible, we would not use the right join at all, though we can experiment it and see what result it will give us. Okay, let's even experiment it. Before we go, let's experiment it. We have like 5 more minutes. Let's see what the right join will give us if we were to run this on the right join. I don't know yet what it will give us, but I'm sure it will give us something really funny. Yeah. We have a lot of useless information. From the right join, we have a lot of useless information, actually. So this, all it means is that these people here, there are no people, but they have managers. Is that not waste of resources? That's waste of business resource. How can you have managers who do not have personnel to manage? Is that making sense? So we don't want to use the right join in fact, we shouldn't use the right join at all anyway. We shouldn't use it at all. Okay, so I'll not include that in the, I'll just not include it in the this thing that I'll send out to you. Okay, so if there's no further question, can we call this a day then, please? Yeah. Kemi, thank you for recording.
You're welcome.